Hi students, so today I am going to teach you about the Pythagoras relation, right? When we are discussing about Pythagoras relation, right? It is going under the right angle triangles, right? Before going for that, we have to have an idea what are the basic types of angles as well as triangles which are included with that particular angles, right? So there are basic three types of angles. First one, that is the acute angle, right? That means for these types of angles the angle is less than 90 degree, right? And there's another one, right? These types of angles, right? This is greater than 90 degree. We are saying it is obtuse angles, right? So, and another one is there, that is exact 90 degree. We are saying right angle. So, including these types of angles, we can form triangles. Triangles mean plane figures with three sides, right? So, if we take a triangle with an acute angle, right? It's a acute angle triangle. And if there's a triangle with an obtuse angle, right, like this, we are saying obtuse angled triangle. And if there's a angle with 90 degree, this particular triangle, we are naming this as right angled triangle. So these are the basic three types of triangles. So today the theory is going under right angled triangle. That means Pythagoras relation is going with right angled triangle. Okay, so this relationship is presented the scientist Pythagoras, Greek scientist, right? So he told that, right, if we have a right angle triangle like this, right? First of all, let's learn about the elements regarding with this right angle triangle, right? So here you can see a right angle there, right? And the next thing is the the hypotenuse, right? Hypotenuse means the side in front of the right angle, right? And these two sides we are naming them as included side for the right angle, right? So these are the basic three things you should learn in a right angle triangle. And now let's learn about the theory behind this, right? So the theory is, if we draw a right angle like this, right? Let's name this as A, B and C, right? Now let's give this side as 3 centimeter, right? And this side as 4 centimeter and this side as 5 centimeter, right? This side as 5 centimeter. Now we're gonna draw a square for this side, right? That means all the sides of this square is 3 centimeters. Square mean all the sides are equal now, like this, right? And I'm gonna draw another square for this side also, right? So all the sides are equal, 4 centimeter, right? 4 centimeter. And I'm gonna draw another square for this side, hypotenuse, right? So all the sides are equal, 5 centimeter. Okay. Now children, you can see, if we take the area of this square, it is B square, BC square. That means one side, if you multiply the length and breadth, it's the area, right? So 3 into 3, it's 9 square centimeter. If you take the area for this square, right, it is 16 square centimeter. 4 into 4. Area for this square, it's 25 square centimeter, right? So according to the Pythagoras relation, right, he's saying if you add the areas of these included side squares, right, it is equal to the square of the hypotenuse, right? The area of the square drawn for the hypotenuse. I think you can see that thing in here clearly, right? This one 9 centimeter, 9 plus 16, it's 25, right? So now you can see how the areas of the particular two sides, going with the particular two sides, that means included squares for the two sides, are gonna equal with the square drawn for the hypotenuse, right? So this is the theory, right? So children, the Pythagoras relation is, in a right angled triangle, the area of the square drawn on a hypotenuse is equal to the sum of the areas of the squares drawn on the remaining sides of a triangle, in a triangle which include the right angle. So that is the basic theory, right? Okay, now let's go for an example question regarding this. So in each and every time we can't draw the square, so as like this, if we take a triangle, let's say PQR, right? PQR, PQ square plus QR square is equal to PR square, right? So this is the equation that we are using, right? Okay, now let's take an example, right? In the right angle triangle ABC, okay, ABC, A, B, C. B is 90 degree. AB 5 centimeter. AB 5 centimeter. BC 12 centimeter. Now we have to find the length of AC, right? To find the length of AC, what you should do, you should apply the Pythagoras relation. So according to Pythagoras relation, Pythagoras theorem, we can say whatever, Pythagoras theorem or Pythagoras relation, right? Square of the hypotenuse, that means AC squared is equal AB squared plus BC squared. We have to find the length of AC. So we are writing AC squared like this. No values to substitute, right? So AB square, it's 5. So 5 square. BC squared, it's 12. 12 squared. So AC squared is equal, 5 squared mean 25, 12 squared mean 144, right? So if you take this addition of 25 and 144, you will obtain 169, right? So 169 you can write, you can take the square root for both the sides, then you will obtain AC as 13. So the length of AC is 13 centimeter. Okay, this is the way of doing the sums regarding under Pythagoras relation. Okay, now let's learn about further applications regarding Pythagoras relation. Another simple question, right? Right. So the question is ABCD is a square, right? A, B, C, D. Square mean all the sides are equal, all the angles are 90 degree, right? And they are telling to prove us AC squared is equal to 2AB squared. AC squared is equal to 2AB squared. So here you can write, if we take ABC triangle, right? ABC angle is equal to a 90 degree. It's the data, given data, right? And this angle is 90 degree. It's the data, because they are saying this is a square, so according to that we know this ABC angle is 90 degree, right? And the next thing is, children, what we have to do now, we should if ABC is 90 degree, then we can prove that ABC triangle is a right angled triangle. It's a right angled triangle, right? Then we can write, according to that we can apply, according to Pythagoras relation. Pythagoras relation, we can write AB squared plus BC squared equal AC squared, right? AB squared plus BC squared equal AC squared, right? According to Pythagoras relation. And we know AB is equal to BC. AB is equal to BC, right? So that is the data, right? So you can write AB squared, right? Without writing BC, you can write for that also AB squared, because AB is equal to BC. It's equal to, the total addition is equal to AC squared. That means square of the hypotenuse, right? So finally you can write 2AB squared. 2AB squared is equal to AC squared, right children? 2AB squared is equal to AC squared. Okay, so like this, with the relevant theory, we can prove the sums like this, right? Now let's learn about Pythagorean triples. What is this triples? Triples mean 3. We all know that triples mean 3. So what is Pythagorean triples? Pythagorean triple means, children, if we take a right angle triangle, right? If we take a right angle triangle, right? If this is 3 centimeter, if this is 4 centimeter, this should be definitely 5 centimeter, right? Because 3 squared plus 4 squared equal 5 squared. So these 3 values are known as Pythagorean triples. So 3, 4, 5 are Pythagorean triples. So we can have lots of numbers like that, right? So if we take 5, 12 and 30, 5, 12 and 30, we can name that also as Pythagorean triples, because 5 squared plus 12 squared equal 13 squared. That means 25 plus 144, it's equal to 169. So these types of numbers are known as Pythagorean triples, right? So that's how children you should learn under this. Okay, thank you very much.